Good afternoon, everybody, and thank you so much for joining us for this iSQI webinar this afternoon on Friday the 13th. We're just going to wait a few minutes because we've got a few more attendees that will be joining us. So if you can just bear with me and we'll get started as soon as possible. Just a minute or two, please. Hi again and welcome again from me, Debbie Archer, Managing Director of iSQI UK. I'm going to start the webinar now, and apologies to anybody who hasn't joined us yet, but time is precious and it's probably a good idea if we just move forward. So I'm absolutely delighted so many people have been able to join us. And very, very appreciative of both Bernard Melson and John Young from TSG Training, who have come here today to talk about what is a hot topic, test automation, and in particular, how to get the right return from test automation. In the first instance, a little bit of information about iSQI for those of you who are not familiar with us. We are a group of companies who have a global presence. Our International Service Centre is based in Germany, founded back in 2004. We have offices in the UK, in the Netherlands and in Boston, USA, and are able to deliver globally. We work with over 500 invigilators worldwide, all of whom are trained, fully trained to deliver examinations to the highest standards. And indeed, iSQI adhere to the highest standards in certification of individuals, which is ISO 17024. Since inception, we have delivered well over 143,000 exams, and indeed we're currently delivering over 33,000 exams per year. We deliver in 6 continents, 100 countries, 10 languages, and an iSQI certificate is most certainly of international recognition. Importantly, iSQI are the preferred provider to multiple iSQI boards around the world, and it's no coincidence really that we wanted to do a test automation webinar. The iSQI have recently launched their test automation certification, and it's useful to, I think, perhaps look at test automation in that context, as well as the returns for organizations from implementing test automation in their organization. A little bit about what we offer, and then we'll move into the content of the webinar, which is most interesting, with Bernard. As mentioned, we're an International Qualifications Board working with the iSQI, also IREB and requirements, TMI, UXQB is usability and user experience, DASA DevOps, and many more. Indeed, over 35 vendor-neutral industry-focused certifications. We develop our own certifications also, including Agile, Certified Agile Tester is very popular, Scrum Master Pro, and some mobile app testing qualifications. We can offer all of the iSQI portfolio of exams, including the new 2018 Foundation. The exams available as paper and online, publicly and after accredited training. Just a little note on accreditation for those of you who are based in the UK. Please, if you are looking for iSQI training, look out for the UKTB accredited training provider logo, because that is a sign that actually the materials and the training has been assessed according to the iSQI standards. Importantly, our exams are available globally via the Pearson VUE network, and I've included a link here for people who would be interested in having a look. If you're working within an organization who is looking to develop your people, then please do contact us, because we have a number of corporate solutions that may be of value to you. To look at our portfolio, please go to the iSQI shop and scroll down to find details of the syllabi, practice exams, glossaries. Going back to accreditation, we are the front desk for a number of the qualifications boards. So if you are a training provider listening in today, please contact us and we'll help you through the process. A little bit about the operational side of the session, just make sure that things run smoothly. Please, everybody put yourselves on mute. There's a Q&A box. We'll answer questions at the end of the presentation, so pop your question in there and we will answer as many as we can at the end. If you have any technical problems, please, again, put it in the Q&A box. We've got people on standby to help. Hopefully we'll be through in about 30 minutes. The session will be recorded and made available later, including on the iSQI YouTube channel, with a number of other expert videos which I hope will be useful. I'll leave the contact information there and you'll be able to see that during the webinar. And I'm going to pass over now to Bernard, who will actually go into the detail and I hope give you some really interesting information about test automation.
Good afternoon, everybody. I hope you can hear me well and you can actually see what we're talking about. So let's show my screen. Who I am. Use a bit of stuff on screen there for you. We won't dwell too much on it. I've been around for about 40 years in IT. John's worked with me for the last 20 years and Debbie with me for the last 8. So really enough about me and let's get on to the subject in hand. So today we're going to look at 6 key topics which really are designed to help you get the right return on your investment from automation, because it is an expensive deal and getting it wrong is quite frankly a disaster. So the 6 criteria we're going to look at today are when and when not to automate, establishing some measures and metrics, because these are pretty important things that you'll be measured by yourself, the iterative life cycle and how automation works within it, the reusable frameworks and architecture you'll need to host your automation assets, because they're valuable things that you want to retain and reuse in the future. Different scripting approaches that you might be able to take, and finally actually managing your returns. What is it you've got from automation, because as I say, it is expensive. But before we think too much about automation, let's look at perhaps a few misconceptions that exist in the industry. I've often heard it said it's a panacea for regression testing. It isn't. Everything can be automated. It cannot, well perhaps it can, but it would be foolish to do so. And it does away with the need for manual testing. It doesn't. So that may be a little bit disappointing or depressing, but we do have some positives before we start. Automation does test far faster than us mortals, me included, even though I think I'm Superman at times. It does take away the laborious side of manual testing, particularly the result checking, which when I was a tester I found oh so painful. And it can maintain high levels of test coverage of test conditions. It frees us up to do other stuff, which is really good. And it can be used to test more applications such as PC builds, which is a kind of a good application for it, but not one that many people think of. So let's have a look at the when and when not to automate. So automation is not a quick fix, we know that, but done correctly, the rewards are myriad and the return on investment can be significant. For organizations who've not used automation before, introducing it requires significant investment in time and money before all the potential benefits can be realized. Don't underestimate this. However, for the purposes today, I'm going to assume you have the green light in your organization to go for it. So before we embark on automating tests for an automation system under test, we must establish that it is feasible to automate it, will be successful, and that the returns are worth the cost. Get the reason for automating an application wrong and you'll have egg on your face and will have wasted a whole bunch of cash. Nobody wants to do that. It's just not good for us. It's not good for the organization. So to avoid this, let us consider what the hard factors are in our decision about whether or not to automate a system under test, as these are key to our business case and benefit statement. 5 key things I look at. The manual test is the time taken, the coverage exercised, and the accuracy of the manual tests. The complexity of the application you're going to put under automation. How complex is it, and what is the underlying infrastructure? And importantly, is that infrastructure supportable by your tool? Again, a bit of a pitfall, that one. The data you're going to need to support it, it does need planning, because without the right data, you're not going to get the right results, or you're not going to exercise the test conditions you want. The frequency, and what is the expected frequency of change for the system under test. If it's never going to change, there ain't much point in automating it, really, is there? And also the lifespan of that system under test. If it's going out of service in 3 to 6 months, or maybe less than a year's time, again, it's not really worth it. But you can't stop there just with the hard factors, because there are other spoiling factors to consider that are outside of your control. You may wish to consider, does your company have a long-term strategy for automation, or perhaps are you the guinea pig? The system under test is not ready, or simply just not stable enough, or even worse, you might find that your stakeholders are not committed. And commitment's a really big deal for those guys, because they're going to spend a lot of money on automation, because I said it's not cheap. So commitment is required. But if you've got some good data coming from both the hard and soft factors, then you have a good reason to embark on automating your system under test. If you don't have the supporting data you need to embark on automation, then the serious advice is don't. If you must, at least wait until the conditions are right. Do it when the conditions are wrong and you'll lose support from above, and it's likely that automation will become misaligned and discredited. Nobody wants that, do they? So one of the first things that we mentioned was talking about establishing metrics and measures, because you've got to really have some of these. Without them, you can't prove what you've done. You spent a whole wad of the company's money, and really they want to see what they're getting. So they're always a key part of what I do, and I always look at four key measures I think I can set and meet. And one about an expectation of my business case for setting about automating a system under test, or an existing system which perhaps has been complete for some time and is now in a maintenance mode. Demonstration, as proving what I've done on completion, because again, so important. It's a bit like your test completion report. What did we get from this? And success factors, it's not sufficient to run a test and demonstrate what has been achieved, but the execution of your test as a regression over time and time again, because this is where your real cash benefit comes back. And in the future, being able to demonstrate the success you'll get when you automate other systems, either in development or long-term standing ones, not having an automated regression pack just yet. So really, test measures and metrics will tell us about the state of the system under test. We need to know that. But automation metrics and measures will tell us about the time to test, the test coverage, the test results, and really importantly, whether our planned test automation system benefits are being realized. And only you can know if the results are delivering what is expected if you've set about defining SMART objectives. And I'm sure you know what they are, but just for reference, specific, measurable, achievable, realistic, and time-based. I think it's important to have those. So look at the graph on your screen at the moment. I guess you're seeing that. And there's 3 key areas in there that I'm looking at. There's pre-automation, post-automation, and ongoing. So before we start, look at the pre-automation points I put down. The time to test is really when we're in manual testing. So that's the measure you're going to start at with a baseline. If you can't do better than that, we might as well head for the hills and go home. Coverage, and that's test conditions or processes, I've used 50% arbitrarily. But if you were testing SAP, it's unlikely this would be so high. Conversely, with a smaller, less complex system and the right data, you would expect this to be much higher. Cost, again, I've used 100% because you've been spending quantifiable time or money on getting your manual test achieved. So again, it provides you with a ready baseline that you could be measured against in the future, or you measure the benefits and the return. Looking at post-automation, I've used a 75% benefit there, because you should be aiming for this figure on completion. I mean, really, I look at 90%, and if I can't achieve 90%, I'm a bit concerned. And if you can't do anything better than that, it's questionable whether the cost and ROI will be returned in the long term. Coverage, I've upped that to 75%. Again, it's arbitrary, but it really depends on the data you use and how you maintain it. Personally, I prefer to start with small data sets with the specific of exercising known test cases and function. Once proven, I take a different tack, and I generally process or progress by freezing a lifestyle data set, a life-size data set, and running tests of pre and post software change. This won't exercise every test case or every condition, but it will exercise the test conditions that exist in your production environment. And using this technique, you won't need to spend lots of money on storage and worry about keeping production-sized databases around. Cost, again, I've used 80% savings, as that is the minimum I would expect. Again, if you can't manage this, it's unlikely that your cost and ROI will be achieved. So essentially on those measures, I'm always looking for 90% savings in time, 90% savings in cost. Now, again, these are ongoing costs, not the cost of setting up the automation system in the first place. So I hope everybody gets that. You might want to look at the benefits as well and subtract the, what you did on the manual from the automation, and see how you've done there. So moving along to the iterative life cycle, here you can see that we've got two cycles here. The one in blue is for the system under test, and the one on the right, the pink one, it looks pink on my screen, is for the automation development. So looking at the iterative life cycle, completed projects not having used automation previously tend to get things done in 2 iterations. But in new projects, we'll need at least as many iterations or probably more, as there are software releases or sprints as become completed. Even if you look at the sequential V-model project, it's highly unlikely that all the automation features can be delivered successfully in one attempt. We need to ensure that the automation team only attempt to create test automation system features or test scripts that can be delivered in time to support the next cycle of system under test testing. If your automation engineers are also working on the systems under test as part of the same team, you've got a little bit of a problem. It may, in this case, be beneficial to create 2 separate product backlogs, one relating to the system under test features and one relating to the test automation system features. Kind of makes sense to me, and we'll say a little bit more on this slide why in a moment. Release and sprint planning for the system under test backlog will need to factor in dependencies relating to the test automation system backlog and vice versa. If the SUT team, system under test team, creates the automated test as part of the blue cycle, the only test automation system features needed to support the test script creation and execution, as created in the pink cycle, will need to be available in time for the SUT test from the pink cycle. So there's a bit of an alignment problem that could occur here. But any testing tasks that have yet to be automated will need to be initially performed in the blue cycle manually, principally because there's no point in automating something that is not proven as correct. It's often the case that the creation of the automated test is included in the pink cycle. A couple of things worthy of note, though, on this particular slide. During development, there will often be the need for several test environments, as the pink cycle is inevitably running at least 1 iteration behind the blue cycle, maybe perhaps 2 or 3 iterations, depending on the size and complexity of a sprint or a release. Think about that one, because it does mean that you're going to need to maintain separate environments, because you can't really have the developer developing software and posting it into the environment in which you're testing, or your application is being automated, because you won't know what you're testing anymore. But once in production, you can run your scripts periodically to check that nothing inadvertent or unexpected has occurred. But in doing so, you'll need to keep a static set of data for comparison purposes. And this will be a smaller data set than the one I recommended for regular change. If you are running your scripts after an upgrade of software, then you might consider taking a snapshot of your production data and then running them twice. As I said, once against the old software, once against the new. If the automation system says there are no difference, then you've little to investigate. I mean, this method saves the requirement to store huge amounts of data long term, saves you the laborious task of checking every result that comes up, because quite frankly, automation is about result checking as well. It's not just about automating the tests. If you do keep the data, a small database to check for inadvertent change or what have you, you may need to manage that data on a longer term, database on a longer term, because your infrastructures or data structures may change, and you won't have that problem with your large data sets that you're using. Okay. Looking at reusable frameworks and architecture, it really is an immutable fact that automation works better when it has a framework built on an architecture to support what you need it to do, i.e. build repeatable, predictable, and reusable regression packs that demonstrate if a system has or has not been impacted by change. Manual checking of results post-change is laborious and error-prone, so you really want to avoid it if at all possible. It's also worth noting here that if the regression pack doesn't highlight any differences, there's no need to check the results, as I said previously. You can, of course, build tolerances into your scripts to allow certain error types or conditions through. This is another way, really, in which you can increase the return you get from automation. Last thing you want in your scripts is to have an error condition occur and the script actually stops running. You've gone home quite happily at night setting off your large automation pack, you're testing your SAP system. It'll take you a few hours, but you had a small error you hadn't thought about and it stopped. Not so good. The big return, however, is one that comes from your framework, where you can maintain your scripts, your results, and a whole raft of other assets that will increase the value the more you use them over time. Really important that we develop our things within a framework that's got a sensible reusable architecture, without which we'll have standalone stuff which really isn't an asset and you'll have to redevelop and throw it away. Commercial test vendors may provide different test frameworks under the guise of tool sets or tool suites. Open source tools may not provide a framework, leaving you to build something suitable to your specific requirements. Whichever you choose, whether it's a commercial product, whether it's an open source tool, I strongly recommend you investigate and invest in having the right framework. The framework provides for different test phases, and these are often introduced by different teams. For example, development teams are likely to introduce frameworks for component testing earlier. System and acceptance testers, who may be initially performing most of the testing manually, will also introduce more. Some of these tools will perform the functions of more than one architectural layer and can possibly be exploited when building frameworks to support system-wide regression tests. And you can see the depth we have of the framework there and the different multi-layers it has. These really are necessary, and I'd encourage you, if you are introducing automation or you have it, to actually look and compare and contrast your framework. It doesn't have to be identical, of course, but they should notionally be similar. It's often a task of the automation engineers, really, to find ways in which various tool sets and frameworks are made to integrate. They often achieve this by creating or modifying bespoke components, interfaces, and wrappers. This is work that often needs to be done in addition to the creation of your automated scripts mentioned on the previous slide. The point is, you can build automation for whatever you like, but without the right framework, you won't manage the different adaptations necessary to support your system under test technology, because there'll be different tests different technologies supported all over the place, different objects used in your development language, whichever is your chosen one. You won't be able to manage your test logs and your test reporting. You won't be able to manage your data, scripts, and procedures, or really help design and manage your test models to suck in manual test scripts and supporting collateral. If you don't have the right framework, then it's unlikely that you will achieve what you set out to, and these four key items I've mentioned will be missing. So if you don't have it, essentially your set of repeatable, predictable, and reusable tests that demonstrate and inform the state of the system under system change, it's going to be difficult to manage that. Your time and money metrics will go flying out of the window. You might keep your test coverage up, but you won't necessarily boost your standing in doing that. So important you have the framework. It really is about you, it's about the system, and it's about the reusability of it. Next one. So let's look at quickly scripting and approaches. A typical objective for test automation is to replace existing manual regression tests with automation tests. That might sound a bit of me teaching people to suck eggs, but really it's a point that needs to be made, and our stakeholders don't always understand that you're going to have to continue to invest in your manual tests and to invest in your automated tests as well to keep things up to date. But for example, we might have 1,000 manual test scripts. If we can translate these into 1,000 automated test scripts, which can be run significantly faster, then we have a measurable benefit, especially if we use the capture replay tool features, which are relatively easy to learn. Although I suggest they're not a long-term strategy, capture replay. It's just really to help you learn. The literal translation of manual tests on a one-for-one basis may look attractive, especially as progress looks easy to measure, i.e. how many of the 1,000 test scripts have we automated thus far, and what are the savings? But the scripting method does not provide any economy of scale and will often exacerbate the existing inefficiencies included in manual tests, especially if these are legacy scripts. So really we look at, I'm not sure if it's the right word, componentizing our scripts, breaking them down so that we've got reusable attributes that we can then use to push scripts together to make a far better result. It saves on the maintenance, and really it's working at the common level. You have a choice about which methods you can use, and many of which use different benefits. You could opt for capture replay, linear scripting, structured scripting, data-driven scripting, keyword-driven scripting, process-driven scripting, and even model-based. And I expect the way technology changes since we started this webinar, someone's invented yet another way of doing this. But it's clear there are many methods, and each has its benefits and drawbacks. Capture replay is the cheapest, but also the least useful. Linear scripting, a little more useful, not too much. The others are more expensive, but they definitely offer you a greater return. Essentially, whichever you use, and I can't tell you which it is because I don't know your organizations, you must consider the original objectives and the technology stack on which your systems are built. Remember, what we're looking at is developing a set of predictable, reusable, and repeatable scripts. And I know I've said that quite a few times, but it's really important for your projects that live in our framework, where they can be used time and time again and results stored and analyzed. Although it requires substantial investments to switch to other scripting approaches, which may require the automation architecture to be modified, the efficiency gains in reductions in script maintenance costs that can be realized can quickly offset these costs. Again, that's about componentization. So back to measuring returns. We've actually done something, we've got somewhere. There are some pitfalls considering your measurements, including often the return isn't there on the first attempt, and that can be a bit depressing at times. But if you got it right, then you will get it right, and it will get better. And in initial attempts, put thought into the task features you need first. Always pilot first to judge whether the test automation system is viable, and expect benefits to accrue incrementally as the test automation system evolves. Like I said, on the first run, it probably won't be that great. You'll have a lot of work to do correcting your scripts once you've written them, and it won't seem like the benefit is there. Stick with it, pursue it, they will. But in doing these things in measuring, we must also make sure costs are measured as well as benefits realized and the right ratios applied. i.e., what are my performance improvements? What are my cash improvements? What are my coverage improvements? What was the equivalent manual effort and time measures needed to be made or estimated for all activities being automated? And realize that actually not all benefits can be quantified. Many can, but you might have systems where you've got to have breaks in the middle. So you can automate one part, you can't automate the next, and you can automate the third piece. So A might be good, B might be bad, and C might be good. So the quantifiable benefits really are just from A and C. B can't be done. But assuming we've got this far, we've built something. We have a framework, we have some scripts, we have some test results, we have something to quantify and measure against our original objectives. The sample on screen is a real one on a program I ran to automate SAP at several clients. The base problem was that it took a team of up to 12 weeks to test an SAP release. Now, I don't know if you guys are testing SAP and you're looking to automate, It's a big program, but you'll know from my experience that actually testing an SAP system is very, very difficult and does take very long. And in the particular case that I had, releases could come more frequently than the period it took to test it. And again, if you're an SAP tester, you'll know that. If a release comes every 3 months, can you test an SAP system manually in 3 months? No. In that situation, the result, so you have a big risk analysis on every release to see what has to be tested and what could not be tested and what the potential might be on the production system. It's a big deal. So for argument's sake, on big systems like this, where you can't test everything in between releases, it becomes a bit of a no-brainer to say we must automate it. It reduces their risk substantially. And plus, in that manual test that I was automating with the people, we never got more than 30% of the function points tested or conditions tested. So coverage was really, really low. And you really had to risk and prioritize what you did. I automated the programs for these two companies, with each achieving startling similar results. Anyway, with the 3 monthly release program of testing, you can see it took around 1 year to pay back the cost of developing the SAP automation program. And beyond that, testing was very cheap, with only the additional costs being to update scripts to reflect change or update data to reflect data structure changes or in the business process itself. So having a quick look at the cumulative costs and payback period, you've got to assume that the cost of development, none, you've already done the development, so the manual tests don't cost you anything. But in my situation, it was costing me £58,000 each manual test over 12 weeks. My automation cost developments were £210,000, but they actually cost very little to run, because essentially the coverage was going up, the function points cover was going up, the team size went down, the day rates were the same for the automation tester, and arbitrarily that gave me a cost of £58,000 to run a manual test, £210,000 to develop the automation, and a startling low £3,500 to repeat a regression test later. So after a year, or after the fourth run, we're in the positive. And actually, you can see exponentially, we would save £1 million very, very quickly. So an example really of test automation giving the returns that we expected and wanted. Hats off to the team. I just ran the team. It wasn't me who did it. So hats off to my guys. So on a quick recap basis, then we've looked at major subject matter today, and we've discussed when and not to automate. We know that we must look at both the hard and soft factors before deciding whether or not to automate. And don't be afraid to say no. I don't think we can automate this. I don't think the returns will be there. Equally, don't be afraid to say yes. Seek advice if you're not sure. The hard factors are under your control and include such as we can do it, should we do it, and what we expect the return on investment to be. The soft factors, they're your detractors, and they're the things that are going to get in your way, and they include such things as, does the organization plan to support automation, or are just on a one-off program here? And are your stakeholders supportive and bought in because they pay the bills? Remember, if you have a system that changes a lot and which will be in place for some time to come, then you have a good candidate. If the system is short-lived, fewer than 12 months expectancy, or you don't have the support, then there is little point. It's unlikely that a return will be realized. As I say, don't be afraid to say no, please. Again, establishing measures and metrics. Before making a business case, you must understand what it is you want from the program. Is it time, speed, accuracy, cost, or all of these? Be careful before deciding, because what you say here is what you'll be measured against. You can't necessarily get all of these returns. And again, these may form part of your, when and when not to automate. I'd urge you to be conservative so that you stand a chance of being able to over-deliver. I worked on 18 months payback for the SAP programs, which I thought easily achievable. I under-promised, over-delivered, everyone's delighted. And while the cost was high, it was an investment that was well worth making, as they're still running those automation packs 3 years later, and the savings are into the millions. The iterative life cycle. For development projects, you will be building iteratively once software has been developed and released. I find it preferable to have a secondary environment for automated testing, particularly as the developers will want to press ahead with the next release or sprint before you've developed and tested your automation scripts. You can't do both at the same time. So please separate them. Reusable frameworks and architecture. This is the essence of good automation, without which you may be limited and achieve a set of static results. But reusable tests are, in the worst case, simple capture replay. Nothing wrong with capture replay, provided it is used as the basis for something larger. Essentially, capture replay is more for developers, one-off tests really, or people learning automation. Please don't adopt this for your long-term strategy. Scripting approaches, data-driven, word-driven or other, it's really up to you to make the choice to ensure you have a reusable set of scripts that you get a decent return on your investment in automation. I can't tell you which of those to use. I don't understand your infrastructure, your technology, or what it is you're wanting to achieve. But I urge you to consider the 6 different things we discussed on those. Managing returns, ensure you underpromise to deliver, as frequently the cost of outweigation can outweigh the benefits. If you get it right, you'll get the returns, and assuming all is well and there is need, the opportunity to build bigger and better automation programs will fall into your lap. But again, the biggest key thing for you is when and when not to automate. You really must get that right. So that's kind of all I've got to say now. And I think we're probably open to questions, aren't we?
Bernard, thank you very much for that very insightful, practical, heartfelt and experience-based presentation regarding the return on investment from automating, getting some real returns. Unfortunately, we've run over and I'm going to have to close the session. Thank you to everybody who has participated, and I'd urge you to please go to our YouTube channel in a few days. We will post the video and we'll also share it for those who have signed up for our newsletter. Thank you again, everybody, for attending. Any questions, drop me a line or drop Bernard a line, and we'd be very happy to help you. Thank you, and hopefully see you all again soon.